So welcome to the Anritsu VTT joint demonstration for D-band civil antenna technology and advanced measurement technology. Jarkko, please give us an overview of the system.
Yeah, sure thing. So from left to right, we have Anritsu's D-band transmitter, then transmit array by VTT, and then on the right side we have a receiver for D-band by Anritsu. Okay, I can give you a brief introduction to our antenna system here. So we are using a transmit array, which is basically a vector modulator sandwiched between two antennas. And then there are multiple of those to form the actual array. So on the input side, we have antennas which are receiving roughly a plane wave. Then they will capture all those signals and feed them to the vector modulators that have been designed here at VTT. Then the signals are modulated in phase and in amplitude, and then they are pushed forward to the output side antennas. And then depending on what kind of vectors are we actually using in those vector modulators, the beam can be manipulated so it can be straightforward or tilted to one side or the other.
So here is the Anritsu measurement system used in the configuration here. So we have the baseband signal generation component at the bottom, going to specially developed A to D and D to A converters used for the TX and RX stages, coupled then to IF generation output and input on the bottom here. These connect to the TX and the RX external up-down converters. These up-down converters are using specially developed Anritsu's in-house technology for doing very wideband D-band measurements. We have state-of-the-art algorithms for doing both level and phase accuracy, and this is automatically calibrated at runtime to give the very best performance for doing modulated signals at high frequency with very wide bandwidth. So now we have the system set up and running in a direct communications link. So transmit signal source here, antenna pointing straight ahead, receiving on the receiver port on the other side. On the receiver monitor screen, we can now see the received signal quality. Because this is a direct line of sight path, we have good demodulation. So this is a QPSK modulated signal, clearly demodulated, and we can see the wideband signal received. So now we have a direct signal, good signal to noise ratio, good quality direct communication.
So currently we are measuring the direct path between transmitter and receiver. We can also demonstrate the beam steering capability by adding absorbers on the direct path, and we can observe from the computer that the signal disappeared. We can go around this by using the beam steering capability and directing the beam towards the reflector on the table. Now that the beam steered, we can see that the signal appeared on the computer again. And we can also demonstrate that we're actually using this reflector with another absorber. So if we place absorber, the signal disappears again.